And a while back, Microsoft introduced Generation 2 of the Azure SQL Data Warehouse platform. And one of the big benefits of this platform was that it provided faster query performance versus the original Generation 1. And so today I want to talk a little bit about how Generation 2 of Azure SQL Data Warehouse gets this faster query performance. To begin, I want to show this diagram of the architecture of the Azure SQL Data Warehouse platform. And the key here to understand is that this platform uses what's called massive parallel processing. So the idea is that we would issue a query to one control node, as we see in the top, and then that control node distributes that query across multiple compute nodes, as you see in this illustration here, kind of in that middle tier. And those queries then run in parallel on those compute nodes to render a partial result that gets rolled up to that control node. Now, regarding the performance of Generation 2, I want to focus right now on the bottom of this diagram, which is the storage. So the data storage for Azure SQL Data Warehouse is actually in Azure Blob Storage. And this is the key feature of the architecture, is that the compute power and the storage are managed independently and separately. And so with Generation 1, all of our data for Azure SQL Data Warehouse was stored remotely in Blob Storage. And so now, flipping to this next diagram, I want to talk a little bit about how and what's changed to enable faster query performance with Generation 2. We still have the same fundamental architecture. Our data is still stored remotely in Blob Storage. But with Generation 2, they've introduced what's called adaptive caching. And that really is enabled by a couple things. Number one, there was new hardware introduced to the Azure platform. So Azure SQL Data Warehouse Gen 2 is running on a new version and a new generation of hardware. And part of that includes SSDs on the compute nodes. And so that's part of where we get the speed from. But what I want to highlight here as far as the query performance is this notion of adaptive caching. And what that means is that when we use column store indexes, previously all of that data was stored, like I said, remotely on Blob Storage. But with the adaptive caching, what it does is it actually brings certain column store segments into the compute node itself. Okay, and so now, depending upon the query that I execute, if my query can be resolved by data that has been moved into the compute node, it reduces or eliminates the I/O required to go out to that remote storage. And that's really the key to how Azure SQL Data Warehouse Gen 2 achieves that high query performance. Now, the other thing about the word adaptive is that the column store segments that are actually brought into the compute node will depend on past query execution. So history, it'll understand, hey, you've run this query, therefore I'll bring in those column store segments that might help you resolve a similar query in the future. And it also will kind of develop a pattern based on what other, if you've run that query, you may also run this query, and therefore it will bring those column store segments in as well. But again, the idea is to bring that data into the compute node and reduce or eliminate entirely the need to read that data from the remote Blob Storage. I hope you found this information useful. If you have any questions about Azure SQL Data Warehouse, please reach out, let us know. Thank you.